All right, today we're going to go over transformations of quadratic functions. On this second slide right here, I would either jot down a few notes or take a screenshot of this slide. I will also be sharing the video, so if you don't have time to write it all down. These are the basic rules for transformations. For example, this is vertex form of quadratic functions. We've been working in standard form, which you can actually get to if you multiply this by itself and then apply the a value and then add the k value. You can get to standard form, but actually vertex form is the best for finding the transformations. So the a value tells you if it is a parabola that goes up or if it's a parabola that goes down. If it's positive, it's more like a U shape. If it's negative, it's more like an umbrella. It also tells you if there's a vertical stretch or a compression. A stretch is when it's more narrow than the parent function, and a compression is when it is wider than the parent function, which you'll see some pictures here in a minute. The h value, which is in the vertex form, is minus h. It tells you if you move to the left or the right. So since the vertex form has a subtraction symbol here, it moves opposite of what your brain would automatically think. So I think positive means right and negative means left, but because the form of the equation has a negative here, it goes backwards of that. So negative is to the right and positive is to the left. And then lastly, the plus or minus value at the very end of vertex form, that will shift your parabola up or down on the y-axis, kind of like your y-intercept. Okay, so let's get started. So this is from your Google form this week, and it's asking you if the normal graph f of x equals x squared was transformed to create the graph g of x, which is x minus 1.4 quantity squared, which of these describes the transformation. So what they're saying is, if your standard form, my pen was white, sorry you couldn't see that. If my parent function is a parabola with its vertex at 0, 0, then what would happen if I have this minus h value here in the equation? If you'll recall on the last slide, if you have a minus h value, it'll move it to the right. And if you have a plus h value, it'll move it to the left. And this is always done in the parentheses of vertex form. So in this case, if it's minus 1.4, then that's going to move us to the right 1.4 units. So we're not looking at a vertical shift at all because that's up and down, and that would be a k value. So we're looking at a horizontal shift, and this one is to the right because it's x minus h. So this one would be f. All right, our next example is problem number 4 from that same Google form. And this time they gave us graphs that we're going to compare. So if you'll notice, the dashed line is your parent function. So that's your f of x equals x squared. Your solid line is the transformation. So they're asking which one is representing the original, which is x squared, minus 2. Notice that there's no parentheses around it. So the last question that we did, it was like x minus 1.4 and they were in parentheses. This one is x squared minus 2. So this has already been multiplied by itself. So all they're taking is this x squared and they're subtracting 2 from the x squared. So if your parent function is at 0, 0, and it's already squared, then the minus 2 is actually a k value. So the k value tells you you're either going to go up or go down. And in this case, minus 2, it works exactly how you would think it would work. So we're going to go down 2 units because this would be plus. So if we start at 0, 0, This one is going to take us down 2 units. This one would be x squared plus 2 because it's up 2 units. These would be x plus 2 squared and x minus 2 squared inside the parentheses. So that's the difference here, is that the squared already happened. So this one is our x squared minus 2. All right, our next example comes from the Google Slides. And a side note on the Google Slides is I already made enough buttons that you just drag and drop them where they belong, and you should use all of them. So you don't need to make any copies or anything like that. All of the little choices on the side, you just drag them over to where they belong, and once you run out of them, you won't need any more of that one. Or you might have put one in the wrong spot, okay? So let's go through and look at these equations and determine what's changing. So in this one, is there an a value? Is there a value in front of the parenthesis? There's not. So it's not going to be a stretch or a compression because it has no a value. Next, we look at our h value. Our h value is plus 5. So x plus h actually makes it move to the left because remember, standard form is a minus sign there. So this one would be I forgot the terminology that they used, a translation, a left translation. The next one is going to tell us the k value. So in your k value, it's the plus 2 at the end, or the minus 2 at the end, and that tells us if we move up or down. And this one acts just like the y-axis. So if it's a plus, then we move up, and if it's a minus, we move down. So this is a translation down, or I don't know the wording that they used, but it's going to move downward. Downward. Sorry, I'm not known for my spelling. And also to the left. So on that Google slide, you are going to drag left translation and translation downward over to number 8. Okay. The next one is number 11. And this one does have an a value, but what's weird about the a value is it's a fraction. So I want you to consider, is it a number bigger than 1 or a number smaller than 1? Well, 3/2 is actually equivalent to 1.5. So because it is a value bigger than 1, it's going to make our graph a stretch, a vertical stretch. It's going to make it more narrow because the number that you're distributing after you've multiplied is bigger than 1. So this is going to be called a vertical stretch. Okay, so the parent function is going to be a little wider than that. And then if you had a fraction that was less than 1, let's say 1/2, it would make the graph a lot wider. Next, we are going to look at our h value, which in this case is minus 4. Because it's x minus 4, it's going to make us move to the right. So that is a right translation. And then lastly, we're going to look at the plus k value at the very end of the equation, and that is plus 1. So remember, plus 1 is going to tell us up or down. And since it's positive, we're going to go up. So that's going to be, I think they call it a translation upwards. I don't have that document open at the moment, but it says something upwards. I do remember that. So you're just going to drag those choices over to number 11. And the order doesn't matter. So if you have vertical stretch at the bottom and translation upwards at the top, I'm not going to care about that when I'm grading it. So don't stress. That pretty much concludes the examples I was doing today, because as long as you follow everything on the second slide that I showed you, how it's moving, the A value, and then so on the A value, neither of my examples had an A value, but if it's negative, it's going to flip it downwards. So it'll say a reflection over the x-axis. That's very important. The vertical stretch, remember, is a number that is bigger than 1. A vertical compression is when it's a fraction that is less than 1. They should have specified that better, because we saw that example where it was a fraction, but it was improper, so it actually made it stretch. So this is a super helpful screen. Your assignments for the week are the Ed Puzzle, which is the video, the Google form, which I did the first 2 examples with you. I think it's only like 10 questions. And then the Google Slides matching. So that's the drag and drop. The extension activity is the Imagine Math pathway. And the reason that I created that for you guys is so that you could help with the student incentive to get Mr. Bingham to shave his head. So if you're interested in Mr. Bingham shaving his head on like Facebook Live or something like that, then get on Imagine Math. If not, it's just extra, so it won't be a grade unless you need it to help you pass. So I hope this is helpful.